Let's now turn our attention to the last topic here on this skills check, which is how can I take a given function, plug different things into that function to set up an expression and ultimately evaluate it. So let's try this here on number 5a. And I'm going to go ahead and make a whole bunch of space to do this down here. So number 5, part A. Notice that I'm starting with the function here, f of x is equal to 2x squared minus 7. Now some of the other functions here are a little bit more complicated, but we'll start with this simple one. I'll let you try the other ones on your own. Our goal right now, remember, is to set up the expression f with x plus h plugged into it minus f with x plugged into it, and then divide everything by h, and then our goal is going to be to simplify. Now h here is just like an extra variable, so don't worry too much about what value it has or anything like that. It's just another variable here. So this is always kind of a strange thing because people will often wonder, what exactly am I supposed to do when I see this f of x plus h? And very oftentimes people will overcomplicate what this means. Keep in mind that you already know how to plug numbers into a function. Like if I was to ask you, what's f of 0? You probably can tell me very quickly. What would f of 0 be? Well, you should come up with, it's negative 7. And how did you know that? What did you do to arrive at that? Well, you simply just plugged 0 in for x and then simplified the result, right? And you do the same thing if I said, well, what happens when you plug in 2? Right? You'd say, okay, well, plug 2 in. So that's 2 squared, and then I'm going to have that's 4. 4 times 2 is 8. 8 minus 7, 1, right? You can get a result. Well, notice, what if I said, plug in a value called a? Well, you would just go wherever the x used to be, and you would just plug in that value. And if that happened to be a number, you could start to simplify. Notice you can do this with anything in the universe, right? I mean, if someone says, hey, I'd like you to plug in a smiley face, you're just like, okay, no problem. Just wherever the variable used to be, I plug in my smiley face, and I guess that's what I have. Now, that's kind of strange, but notice that it works perfectly consistently with the idea of plug in x plus h. So take a look at how I actually go about doing this. I'm going to take what I have right here, and I'm going to say that I can re-express this. I'm going to have f of x plus h. I'm going to have minus f of x. And I'm going to take all of this and divide by h. Now, in my first set of brackets, I'm going to write down what f of x plus h would look like. So I'm going to write down exactly what my function formula looked like. In both of these spaces, because in each of these I'm just going to plug in something different. So here I'm supposed to replace the variable x with x plus h. No big deal. So I just go wherever the variable was and I put an x plus h, just like I would have done with a 0 or a 2 or an a or a smiley face. Over here I'm asked, go to wherever the variable is and put down x. So I just go, okay, that's it. Now I just have to simplify this up a little bit. So let's see what we come up with here. Obviously, I'm going to have 2 x plus h quantity squared minus a 7. And I have minus over here a 2x squared minus a 7. Now I'm going to be careful here to distribute this subtraction. And then over here, I'm going to square this quantity. So to do that, I'm going to go ahead and have 2. This is going to be x squared plus 2xh plus h squared. You may have to double check me on that. I know I did that really fast. So if you need to, write out both sets of parentheses and actually do the distributing there. But you should be able to confirm that that's what I would end up with. Now over here, I'm going to get a minus a 2x squared and then plus a 7. Again, all of this, whoa, this is a bad line, but all of this ends up over the value of h. Okay, so let's just keep going. Notice here now, I have a 2 to ultimately distribute in here to all of these different terms. So I'm going to have a 2x squared plus a 4xh plus an h squared minus this 7. Notice right now I'm going to drop these big brackets because I don't really need them. And I'm going to have minus 2x squared plus 7. All I'm doing right now is just trying to simplify this down as much as I can. Now, while it looks like I've made things a lot messier, you might notice that several things in the numerator now can simplify out. Notice I have a minus 7 and a plus 7. I have a minus 2x squared and a plus 2x squared. And so if I write out what I'm left with, I just have 4xh, h squared over h. And I can actually simplify this a bit further because, like we talked about several videos back, there's something in common in the numerator, and I should factor that out so I can see if anything can cancel from top and bottom. If I take an h out of the numerator, I'm going to be left with this. And now, of course, I can see that my h over h is going to turn into a 1, and so I'm really just going to be left with 4x plus h. So this is the basic idea. And the other examples in parts B and C will help you to try to repeat this same process. There's no difference in terms of what I have to do with these other questions and what I did here on part A. I'm just starting with a different function, and so the simplification process might be a bit different. Maybe instead of squaring a quantity, when I have this x plus h plugged in, maybe I'm going to have something complicated like 2 radicals being subtracted or 2 fractions being subtracted, and you'll see that when you write out the detail. Very interestingly, in part B, which is the one I would suggest you go try right after you end this video, is that you'll actually be able to use the ideas of the conjugate to help simplify the expression that you end up with there. So go ahead, give that a try, and hopefully this gives you a really good solid footing so when these topics come up throughout our first unit, you'll be ready to tackle all of the algebra stuff, and you'll be able to really focus your attention on what's new in calculus.